Hi, I'm David. Today we're going to look at cosine of arcsine of 2x. All right, we want to unpack this expression a little bit. We're asked to write this in an algebraic form. Well, there's a trick to these, and the deal is that whenever I have an inverse trigonometric function like arcsine, and I'm plugging it into a regular trigonometric function like cosine, it's a good idea to think about this thing, arcsine of 2x, as an angle. So let me go ahead and call it something that looks like an angle. I'll say arcsine of 2x equals theta. Once I've written that, I can use what I know about inverse functions to rewrite this equation in a way that's maybe a little more comfortable for me. Arcsine of 2x equals theta is the same as writing sine of theta equals 2x. All right, now this is a little more comfortable, and I can think about this in terms of a right triangle. I also know that if arcsine of 2x equals theta, when I'm finished here, this is going to be cosine of whatever that theta is. And that'll be a little easier for me to deal with. Okay, sine of theta equals 2x. I know from trigonometry that sine of theta is opposite over hypotenuse for a right triangle. So let me draw a right triangle. And I'll put theta right here on the angle. And then I'm going to want to populate the sides of this right triangle. Sine of theta is opposite over hypotenuse. And I want this to equal 2x. So I could pick any ratio I like that equals 2x, but probably an easy one is to write sine of theta equals 2x over 1. Now, if you wanted to write 4x over 2 or something like that, you could, but you don't need to make things more complicated than they need to be. All right, so sine of theta is 2x over 1, so the opposite is 2x, and the hypotenuse is 1. Now, when I find cosine of theta is going to be adjacent over hypotenuse. I have the hypotenuse, but I don't have the adjacent. So the rest of this problem really just boils down to solving the Pythagorean theorem for what this other side is. Let me call this side S, and we'll solve for S. If I use the Pythagorean theorem, I know that 1 squared equals the quantity 2x squared plus s squared. I can't forget about the parentheses here. I'm squaring 2x, not just the x. If I simplify this, I have 1 equals 4x squared plus s squared. And I'm going to try to solve this for s. Let's see, I could subtract 4x squared from both sides, and I'll have 1 minus 4x squared equal s squared. And now I just need to take the square root of both sides. I don't have to worry about a plus or minus situation coming in here because this is a positive length right here. So I am just going to use the positive length. If I take the square root of both sides, I have 1 minus 4x squared equal s. If I take the square root of both sides. And that's what I've got as my other side here, the square root of 1 minus 4x squared. Okay, it might look nasty, but it is the other side, and it makes sense. And you could always check your work. If you wanted to square this side and square this side and add them together, you would see that you would get 1. Okay, now I have all the information I need. I know that my cosine of arcsine of 2x is really just cosine of theta, and I know that cosine theta is adjacent over hypotenuse. So I'll write that out. Adjacent is the square root of 1 minus 4x squared. And the hypotenuse is 1. And just to make things a little more nice, I could take out that 1 because if I divide by 1, I just have the original expression. So it's the square root of 1 minus 4x squared. And that's my final answer. Thanks for watching.